Hello, Michael Borresen.
Hello.
You came
Hello,
with-
Korea. It's nice that you arrive here, and hope you have a few pleasant days here.
Yeah, we have a real nice time in here.
Yeah,
We
yeah.
came with the new version of speaker here,
Yes.
M series.
Yeah, this is the flagship we have.
Yeah.
This is the M6. This is as nerdy and how deep we can dive when we really get into the realm of making every single tiny bit as good as we have the ability to do.
So we have to say it's the pinnacle of the speakers, right?
It is the pinnacle of our technology. Everything merged into one speaker, yes.
And the unit has changed compared to the Z series.
Yes, the units are in almost every single detail different, but of course they build on the same ironless magnet system that we have in the series. But the basket is different, the magnets, the membrane is different.
Membrane.
Yeah, the membrane, if you look at the membrane, it's a 4-layer membrane here.
4 layers.
So behind this, the front here is a titanium skin. The titanium skin is 4/100th of a millimeter thick. And of course that cannot be a membrane in itself. This titanium skin is then coated in our particle accelerator. So they have 5 layers of coating on them. And diamond is 1 layer, tantal is another layer, zirconium is a 3rd layer. So they have layers projected to them and embedded in the surface of the titanium. And that's why it looks this dark grayish color. Behind the titanium layer there is a spread toe carbon and a honeycomb and another spread toe carbon. And when we select the spread toe carbon, it's because it has 2 directions where it's very stiff, and then gradually it becomes, when you come 45 degrees on that, it's actually pretty soft. And that means that if you start looking at the circular stiffness, it's different all around. And the main resonance you always have in a speaker membrane is a standing wave between where the voice coils is attached and the edge. That area can start swinging opposite of the membrane moving, and that gives us a suck out. But because the stiffness is different all around, this resonance cannot happen because it would be a different frequency everywhere.
So you made with really thin titanium skin and the carbon, multiple layer of carbon, so you achieve extremely fast and precise.
What this does is that we have a membrane that's still very light because the added weight is just 4/100th of a millimeter thick, so it's very light, the membrane still, and very stiff. The Nomex, 4 millimeter Nomex and the 2 layers of carbon makes a very stiff membrane. So it's very stiff, and some areas extremely stiff. So it goes from very stiff to extremely stiff. So you still have this low mass, and you can push it, but it does not ring anywhere. It has no resonances because they are cancelled out because of this variant stiffness.
So you did some change in your mechanical grounding system as well?
We did that, but we also did other changes to the driver. And I think your friend here can take photographs of that driver over there. And if you take a look at it, we have one live you can take. If you look at that, the basket is a 3D optimized structure.
Yeah.
And what you optimize for is Q in ringing.
Ring.
Yeah, the Q, when you will always, when the membrane moves in, it puts the frame in compression, and when the membrane moves out, it moves the frame in tension. So you have vibration built into that frame from forces. That frame has to carry all the forces of the energy that the speaker projects out. And of course it will excite any resonances. And if you have any resonances that has a high Q, that will start ringing and continue ringing when the speaker is playing. But having low Q means that they are not so big.
Are you talking about the Q factors? Q factors.
Yeah, the
right?
Q factor. Yeah, in the resonance, and the material we use for the basket is zirconium, and zirconium has a tone that we like. Aluminium does not have a tone we like. Aluminium is very bright and brittle, where this one, the tone of that, when you listen to it as a material, is nice and soft. So the tones are different. So the basket out of zirconium, and with the Q factor optimized and the flow optimization done by AI, creates a frame from the driver that is significantly different and much lower in noise than the traditional die-cast aluminium. But of course, the cost of doing that is extraordinarily high, and the price ticket of these speakers is high too. But that has a good reason.
Okay, thank you for the explanations for the speakers. Now, who is the best to know about the entire system of the audio group Denmark? You have manufacturing the speaker and amplifier as well.
Yes.
And also cables.
Yes.
So
the thing is, when we talk about cables, when you know what's good for cables, when you know the mechanisms that makes for a good cable, then you also know because the elements and the problems and the ideas are the same. So when you have a cable, it cannot be a good antenna. We need to prevent it from being antenna. We need very good mechanical stability. We need good grounding. We need low inductance. Those fragments and those ideas are translated into electronics. They're translated into speakers. So when we have these three columns of type of products, we can transfer knowledge and know-how between them and grow the performance of each.
So the same physics applies to all the systems like speaker and the cables and amplifier as well.
The same principles, need to apply. On this show, in terms of peak products, we have of course the M6, which is our flagship speaker. We also have new electronics in the 880 range. And one thing we have a streamer with a built-in DAC, a streamer DAC. And there's many good reasons for building the streamer and the DAC together. It's because when you receive from streaming high resolution file formats, they don't drive very good outside the box. Yeah. So but they have the I2 square. So you can transfer that directly into the DAC. And what we do there is then we take the I2 square data we get, and we upsample that instead of 2 or 4 or 8 times, we upsample it all the way to 22 megahertz. So we push the digital format up in very, very high frequency. But in that, there's embedded the analog signal. So we take the analog, which is between maybe 20 hertz and 30 kilohertz or whatever, depending on what kind of resolution you get in and what kind of bit depth you get in. But it's there, so we only have to get rid of the noise. So instead of having a DAC process, that is a switching process. Where you switch something.
Yeah, of course.
You have now the analog signal, and you have the digital high frequency signal. Yeah. So you can do that as a continuum rather than a discrete process. Yeah. And that is that changed the game of D to A conversion from something that is pointing to something that's like an analog, like a turntable or a tape plays from below. So I think that is we have great expectations for that, and we see the performance is extremely high.
And is there a reason that you stick with the RCA cables, not with the balanced one?
Yeah, I think balanced are well suited for professional.
Yeah.
And the reason balanced is that it has common mode cancellation. So that means that if you have a big signal next to it and it bleeds into, it will not add to the signal. but subtract from the signal. Now in terms of hi-fi, where you maybe have 2 meters or 3 meters, and you only run signal at the time, basically, because you have one source you listen to and the others are turned off, then balance makes no sense. And what balance needs is a balanced signal. That means that if you put something into an amplifier and it has to go through a volume control, which is almost impossible to do exact in a balanced configuration, or at least the way we do it in a balanced mode. That means you have to convert the balance to single-ended and the single-ended to balance, only to fulfill some idea that a cable in some respects or in some circumstances is better. So what we do and what our emphasis is to have a strong ground in our cable, so the signals are, the single-ended signals are extremely preserved because they run in the same shield as the amplifier runs in. And in that respect, for hi-fi, there's absolutely no doubt that single-ended is the better performer. We have tested this many times and seen this many times.
Now, from the D series, the cable is something that runs with the power, right?
Yes.
Active cables. Can you tell me about that?
Yeah, what that does is that it charges up the dielectricum in the cable, so that the signal is always never have to empty charge out of the dielectricum or put charge in. Now the dielectricum is Teflon, so it's not really prone to charge. But anyway, if you charge the dielectricum and push it up, then that is a good idea. And then there's active noise cancellation built into these small boxes. Yeah. And that noise cancellation means that you put a low impedance system in place that prevents the cable from acting as an antenna.
So you're talking about the Tesla principle inside?
Yes, yes. Yes, we are exactly talking about the Tesla coils inside.
And finally, could you tell us briefly about the new lineup, the Axxess system?
Yeah, the Axxess is sort of like when we work with the Aavik electronics or the Børresen speakers or wherever you gather knowledge, and at some point you have to say, okay, what are the most important parts of this knowledge? So we took maybe 3 or 4 of the most important elements and said, okay, if we do that and stick to that and do that is a cost-effective way, it's absolutely possible. What can we actually do for a more modest priced product? What we have in the Aavik and the Børresen and the Ansuz is that often cost is not an issue. Yeah. So our products tend to be in the higher end of the price spectrum. But Axxess, we create the Axxess brand and the Axxess line to be accessible and affordable. So we made that machine as a unity with 3 elements built in. So there's a streamer, there's a good DAC, and there's an amplifier. So it's a one-box high-end solution for more people.
And maybe in future the user of Axxess goes up to the Borresen and Aavik.
Yeah, exactly. Well. So what the plan is for that in the future is to bring out a variety and a range of products that are accessible but has good quality. So it should be always in the top end of price performance, regardless where else you look in this industry.
Okay, thank you for your long
Yeah,
interview.
you're welcome. It's nice.
Okay.
Yeah.
Oh, thank you.
I'm happy.